Hey, what's up, guys? This is Chung here. So today, I want to talk about this 968 problem, binary tree cameras. Uh, it's a hard problem, but I think it's not. Yeah, I can say it's a kind of hard, but as long as you can get the different like types of scenarios, I think you should be able to come up with at least one solutions. Okay, so you're given like a binary tree, right? So binary tree means that only two child nodes at most. And we install cameras on the nodes for the tree. Okay, and each camera at a node can monitor its parent, itself, and its immediate children. So which means that, for example, this one here, right? So for if you install a camera here, so of course including itself, uh, all his all its parent and its two two children's uh, are considered to be monitored, and it asks you to calculate the minimum number of cameras needed to monitor all the nodes of the tree. Okay, so yeah, so basically that's the description of the problem. You know, every time when you guys see a tree problem, of course it's a DFS, right? So because with the tree there's you have to do a DFS so that you can traverse to all the nodes, right? And with this kind of like minimum or maximum thing, you have to do a DFS search. Basically, you know, from the current node here, you're doing some like DFS traverse, and then you're collecting all the data from bottom up. You're collecting all the data here, some here, go and then keep going until you reach the root here, right? Solve a that's how you typically solve the tree related problem here. And but for this problem, the difficulty for this problem is that, you know, since there's like a camera here, then it means that uh, a node basically, you know, they're like different scenario for the current node. Let's say we have a this is a current node, okay? This is a current node, and this node has some children, okay? And since we're only caring about the you know, for the DFS search, right? So all this in the current DFS function just cares about is it's what kind of value this one the current node can get from its children. So which means that we only consider the current node and its child nodes. Okay. So and since we have a camera here, right? So basically there are like three scenarios here. So with the current node here, you know, a camera can be placed at this node. So that's the first scenario. And the second one is there's no camera on this node, but it is covered by a different camera, either from top or from bottom, right? That's the second. So this one is covered. Okay, right. So and the third one is the node is not covered by anyone, right? So basically it's not covered, right? So basically that's the three status of each node in this graph. Okay. So with that, right, I mean, so what does this one tell us? So if you can figure out the three status for each node, it means that each of the DFS function needs to return all these three nodes here, all these three status, because based on the different status, we'll be calculating the current node's result for all these three scenarios. Okay. Mm, cool. So uh, let's say the first scenario is there's a camera on this node. Okay. So if there's a camera, so the first one is there's a camera on this node, right? So what does it mean? It means that, we it's basically we have a one plus are like a left and a right. Whatever we get from left and whatever we get from right. Okay, because since we have a camera on this current node, we don't care about if if the child node if any of the child node has a camera or not. Okay, because basically if the current one has a camera, so the left the child node they can choose from any of these three scenarios here because we don't rely on the child nodes to cover to monitor our current node. So basically these things, the child node and left child nodes, the left child node and the right child node can be anything. Basically any of these three options is fine. So that's the first scenario, right? So how about the second scenario? So the second scenario is this. Second scenario is the current node doesn't have a camera, but is is covered. So if this one doesn't have a camera, how can it be covered? So it can only be covered by the child node. Okay, I mean, I know even someone could say, okay, so what if the current node can also be covered by the monitored by the parent node, right? But uh, but since we are at the current node here, right? And okay, but since we're considering a subtree, right? So basically, this DFS method, basically what this DFS does, it means is that we use with the current node as a root node, right? So basically, for within this DFS functions, we're only considering a subtree which has the current node as a root node. So which means that we shouldn't consider this root node is being covered by the parent because this DFS it doesn't care. So the parent of the current node doesn't exist in this DFS because this node is the parent. Okay, so now I mean now if this node the second case is is it's covered but there's no camera on it. So which means that either the left either the left child or the right child needs to have a camera, right? So which means the camera is the first case, is the first case. Or we can yeah, is this the first case, right? So we can just get the minimum of what? Of left child of left has camera or the right has camera. So that's the second case, right? So what's the third case? The third case is the uh, the current node uh, that is not covered at all. Okay, so if the current node is not covered at all, it means that both the left and the child node cannot have the camera on it, right? So which means it's gonna be uh, the second the second and the third case, right? Yeah, you know what? Actually, let me try to write down these things here so that I'm okay. So basically, the case one, right? So the case one is uh so the case one. Let's do the case one here. Case one is the current node is not monitored. Monitored. How about this? So, and the case two is current node is monitored, but no camera. Okay, there's no camera. Case 3 is the current node has camera, right? So that's the 3 case we have here. So with these 3 cases, right, when we define the DFS here, we're gonna have a node here, right? So first we're gonna have a left, right? So we're gonna define the left DFS node left, and then right equals DFS node right. Okay. Yeah, and then now we need to have a case 1, 2, 3, right? So we have case 1 here, right? So what's the case 1? Case 1 means the current node is not monitored at all. So which means that I mean uh the left node I mean has to be monitored. I mean basically it means that the left node cannot have the camera, but the left node has to be in the case 2 here because we cannot allow the the left node to be not monitored. So which means here, so we have a left close to 1 here. I mean, I'm gonna have 0 since it's 0 base, right? 0, 1, 2 plus right 1. So the reason being, so the reason we cannot use case 0 here is because, if the right one, okay, so if the child node is not monitored and the current node is not monitored, then of this case is not a valid case because our goal is to have all the nodes to be monitored. So which means that in this case, for case 1, the only options we have here is to so for the left child node is monitored but no camera on it. Okay. And the case 2 is like the case 2 is current node is monitored, but there's no camera on it. So which means that we need to get, so either the left node has a cam if the left child has a camera or the right child has a camera. Okay. So if the left child has a camera, then it's a case 2 here, right? And if the left child has a monitor, it means that the right child doesn't need to have a monitor. So which means that uh, but of course the right child node also needs to be monitored. So which means that it's gonna be the minimum of the right uh, basically the second and the third the second and the third case because for if the left one is already have a we are sure the left one has a camera, so the right child can either have a camera or it doesn't have or no camera. So we have two options here. So that's the first case, and the second case is uh, the right the right one has a monitor, right? And then of course, but so and the left one can have a monitor or doesn't have a monitor. It's fine. So that's the case 2. Okay, I'll have 0, 1, and 2 here. So then what's the last case? The last case is the current node has a camera. So which means that so we have a camera here, right? So it's 1 first, and then so in this case, the left and the right can be any of these cases because we don't care, right? So because even though we can even include the case 0 in this case because even the 0 is not monitored, right? Because we have a current because we have the current one has a current node has a camera. It can also the the left child and the right child, right? So in this case, we can just get everything from the left minimum and plus the minimum of the right. Yeah, and in the end, we return all three cases here: case 0, case 1, and then case 2. Okay, so yeah, and I think one thing there's like a tricky edge case here is that if the node is empty, basically if the node is none, so what should we return here? So that's for the case 1 here, this is the special case. Let's say we have 4 nodes here. Okay, and for this last node here, so let's say we are at this node here, and for case 1, how can we calculate the case 1? Case 1, what does it mean? It means that the current node is monitored but no camera. So it means that we're trying to get this value, right? This value from the child node. But in this case, there's no this current node doesn't have a child node. So how can this one be covered, right? Of course, still forget about the parent node because with this DFS here, this one we only know the subtree uh, with this node as a root node. So basically, there's a single subtree, the subtree with a single node here. So in this case, actually, we should, if this thing doesn't have a left child, right? So what does this mean? Uh, it means that the right child has to have the camera to cover this one, right? So I mean, if we simply return like 0, 0, 0, 0 here, right? I mean, we'll have an issue here because in this case, right? So let's say we are at like a case 1 here. Uh, we should return 1 because to cover this one, if this one doesn't have a child node, I mean, we basically it means that we have to put a camera here. That's but if we're returning 0, 0, 0, right? So this formula will definitely give us 0, but instead we need 1 here. Okay, right? So and same thing for this. That's for the case this for the leaf node. But for the general case, right? Let's say there's a node here, like it only has like a left child, right? The left child, and but there's no right child. So in this case, what do we have here? We have a so left child is fine. We have a left 2 here, but for the minimum of the right one, uh, so okay, so that's the other one is this one, right? So for the if this one doesn't have a right child, so for this case, the right the right 2 here will be 0, okay? And the minimum of this one is on the left side, right? But in this case, assuming we need like a second, so in this case we're assuming this thing is monitored by the right child, right? It's monitored by the right child. So in this case, we have to do a 1 here. Yeah, so that we can cover these edge cases, right? For the ones that doesn't have either a left child or the right child. Hmm. I mean, if you guys still don't quite get it, I mean, another way of doing this is like this. So let's assume we don't set 1 here. So which means that in here we have to do a few uh, scenarios here. Basically, like I said, if there's no child for this node at all, right? So what do? We do a case 1 equals to 1. It means that okay, so we have to set a camera here. Okay, right? Then okay, else if not node left. So this means that okay, so the current node only has a child node. Sorry, only has a right child. It doesn't have the the left child. Okay, so in this case, what this case one is gonna be? So it's gonna be the right of 2 here. So right, because the in this case we have to use the right child to monitor the card node, right? Because the so if so that's actually equivalent to this one, right? Because if we are considering this one as well, right? So that's going to be the left will be equals to 1. Oh, sorry. In this case, the left 2 is 0, right? And the minimum of right one, probably this one is also going to be a 0 or, or something, right? Because this one is including the case 1 here, right? Which is the right child that does not have have a camera, which is not right, right? So similar for this one, else if not node right? So if the right node does not exist, so which means that the card node has to be monitored by the left node. Okay, so else is this, right? So else is this. Else this here means that this child has both the left and the right child. Basically, this one is for the case this node has both the left and the child node. If we are returning like 000 in this case, for the non node, right? Okay, yeah, I think this should. Okay, did I? Yeah, and in the end here we are like returning what? We're returning the minimum of the we do a DFS. We do a DFS of the root here, but we have 3 values here. Okay, so which are the values we need here? Of course, we need case 1 and 2, right? Because for case 0, it means that the card node is not monitored, but we need to monitor all the nodes, right? So in this case, we have to do a minimum, right? Minimum of this one gonna be starting from 1. Okay, right. So that's the answer here. Submit. What? No. Uh, sorry. Uh, hmm. For case 0, we have like this. Uh, hmm. I think it's probably here, so not. Okay. Yeah, cool. So yeah, so this thing works, right? I mean, and like I said, since I'm just trying to explain the edge case for this one, right? I mean, another easier alternative for this one is like I said, we instead of this one, we do a 1 here because for the other side we use the left 2 here. So if we put a 1 here, that can handle this case for us. So we can just simply remove all these things here. Okay, we can remove everything, and then we just keep these things. With this can handle the edge case for both the left and right side. Yeah, this should just work. Cool. Yeah. I know this. I feel like I did like a terrible explanation for this one. Um. So and this is a hard problem, and it's hard to explain. I don't know why, but anyway, thank you so much for you guys to watch this video, and let me know what you guys think. And okay, stay tuned. I'll be seeing you guys soon. Yeah. Bye bye.